Good evening, everybody, on this fantastic Wednesday evening on the 22nd of October, 2025, depending on where you're watching this from. Some of you, it is already Thursday, so happy Thursday to some of you. So we're going live tonight, and the reason why we're doing that is there have been some notable concerning changes in the evolution of Tropical Storm Melissa out ahead in the next 5 days, and we'll be going through all of the models for you all tonight because this has the potential of becoming a historic hurricane out there in the Western Caribbean, and it could get very close to Jamaica. So we'll be breaking down all those details in tonight's live stream, and if you don't believe me, look it up on X. I was watching Mark Seth's video today and some other people on X. This could be a historic event because I'll explain why that is here in tonight's live stream. We're going to break down things very good. So first of all, we're going to start looking at... I just got home from work, so bear with me here as I shuffle things around here. So first of all, this is what we have with Tropical Storm Melissa. All this convection, while it looks impressive, that is not the system. Our system is pretty much over here now. This is very, very offset. The vortex is so tilted that there is probably some signs that some of the convection is now decoupling away from the circulation entirely. And actually, this convection is headed slowly towards Aruba, where it is not supposed to be moving towards. The convection is supposed to be over our system, but instead, we are not seeing that. And you might be asking, why is this so tilted? What are we seeing out there? Well, the problem here that we're dealing with Tropical Storm Melissa is it's facing some pretty strong vertical wind shear. And remember, vertical wind shear is not wind by itself. It is a wind direction change with height. That's the definition of wind shear after all. We have easterly winds here trying to trying to usher the storm westward. I know it's hard to see my pin here, so let me fix that up here. So what we have is low-level flow trying to usher the storm generally. Man, this is glitching out on me. Sorry about that. So let's pause it here. So the system is trying to be ushered westward by the low-level wind, but the problem is we have upper-level wind that is doing this, coming in out of the west-northwesterly direction, right? And that is vertical wind shear, a change of wind with height, and the system's not going to thrive very well with that shear because it tilts the vortex. The vortex is not vertically stacked. You want vertical symmetry to the vortex for it to quickly organize and intensify. Think about this. And I saw this on an analogy off of OpenAI earlier today. Think about a chimney, right? If you blow the smoke in one direction very hard, you're going to tilt all that smoke, right? The smoke is going to it's not going to go straight up into the air and spread out, right? Helping to vent that heat away. It's called ventilation. And so what we end up seeing here is there is ventilation, but it's not efficient to lower the surface pressures over our cyclone. In fact, there's no deep convection at all over it. How about that? And as long as that is present, we're not going to get a system that's going to intensify here. So the question is whether or not will that change, and it does look like that will change in a couple of days or so, and probably in about 3 days, more like that's what I'm thinking at this point. And so the reason why we're seeing vertical wind shear is because of this upper level trough, and man, tropical tidbits tonight is it really bugs me that these images don't load in properly. So you can see here, there's a trough up here to the northwest of the system, okay? So we have this little upper level northwesterly flow curving around, and we see flow doing this in the water vapor imagery, right? So it's hitting, we have our system that's over here, and so it's hitting our system pretty hard out of the westerly direction is what our shear is doing. And then we get this flow that is doing something like this. So you can kind of imagine There's no anticyclonic flow. What we want to see is very symmetrical outflow in all quadrants of our system. Think about this. The system is not breathing very well right now. It is suffering from breathing problems because of the restriction. So what we want to see is the outflow in all quadrants, and we are not seeing that tonight. Even so, the Milky Way Cirrus was earlier there. It now looks like the outflow is a little bit more restricted to the west now, indicating that vertical wind shear continues to increase over the system. Whether or not will that abate, it does again look like it's going to abate. Hopefully, well, I should not say hopefully in this case. We do not want a strong system. But unfortunately, it is going to abate in about 3 days or so. And I really pray that this thing does not take full advantage of the ocean, because if it does, we are going to have a big problem ahead of us, possibly, again, historic levels. And I really hope that doesn't end up happening. And so the latest recon fix here, man, this is pretty wild to see on a leg mission going into the system. So you can kind of think about it this way: the airplane traveled through this part of the system, flew around, and did this. All right, and then they did this, and then they flew back in, and they went out again, and now they're coming back in for their next pass through the system. And on their latest pass here, there is no wind at all. See these circles right here? That is wind that is not being observed from the aircraft at all. That is very light wind. And it's like, man, like, is this even a tropical storm? What it appears here is it is a tropical storm. We are seeing winds that are about 15 knots. And there is still this little piece of tropical storm force wind here, but overall the storm is very disheveled, very unorganized at all. And one could even argue if this is a tropical storm at all when it comes to its wind field, because of course what you need is winds of 34 knots or greater, much closer to the center, and we are not seeing that at all tonight, with pressures that continue to go up now, right around 1,005, 1,006 millibars. Actually, the pressure yesterday was actually lower than the pressure today. So we have actually seen some weakening with the system, and this is what is concerning about a system like this, is it's weakening, meaning it can go further west and not make the turn to the north, like what most of the models still illustrate. And so therefore, there's a great ton of uncertainty with exactly how this is going to all evolve. And so therefore, we are going to go to the European model. Before we actually get to that, I want to simplify things and looking at tropical tidbits. There we go. Thought my screen went black for a second there. It didn't, thank goodness. So we're going to use the 18Z run of the Euro. I hate timing things wrong, but we'll get our 0ZN run shortly here. But I wanted to show you all the steering flow with this system, because that is the biggest challenge of yet. Is, for one thing, if the system's not vertically aligned, well, it's not going to feel the upper level winds as well, as efficiently. And so it's going to follow the otherwise low level trade wind flow that is barely helpful in itself. Because the system is moving very slowly. In fact, if we go back and look at the latest fixes here, I would probably imagine this is only moving at about a mile an hour. So it is not moving essentially. I mean, we could all walk faster than a mile an hour, right? Literally, like, go outside right now if you want and walk a mile an hour. You're walking as fast as the tropical system is moving. Yeah, that's pretty slow, all right? But the good news about this is there's no deep convection over the system, so anyone getting, well, this is well away from people, but if this was a lot closer to land, this would not cause a whole lot of problems because it's not very strong in the first place. But the question is will this stall continue? And it does look like it's not going to go too well. So looking at the European model, 500 millibar upper level flow chart, and we have to understand how the atmosphere behaves here, because when you're dealing with a vertically stacked vortex, the system's gonna feel deeper into the atmosphere, right? It's kind of like if you reach your hands out and on a windy day, the winds up here on top of your hands are going to be stronger than the winds exactly down at ground level, like literally inches above the surface, right? You're basically feeling with what the storm is feeling. And so when we look at the upper level steering flow here, this system is fairly shallow. It is not very deep. As you can see, there's no deep convection over the system. So the vortex is either very tilted. Two, it's possibly being decoupled right now, and we are going to have to wait to see if there's deep convection over the center later on in the period. And thirdly, the system's going to follow or feel the lower half of the atmosphere instead of the upper half. So now the question remains is, will this become vertically stacked enough, or at least enough to where the system can feel more deeper of the atmosphere? And the answer to that is it doesn't look all that great. The system's gonna have a hard time feeling the upper parts of this the steering flow here, because we got to understand, if we look at the 200 millibar flow chart here, let's go to 200 millibars. What is our wind doing? It's doing this, right? Our flow is doing this. We don't have that mid-level ridge really well in place here over the Gulf at this particular level. 200 millibars, by the way, is 38,000 feet. And so you're getting westerly flow. So you can imagine if the system was more vertically stacked and more coherent, the system would, in theory, go pretty much towards Hispaniola. But because our system is shallower tonight than what most models illustrated, the system is not going northeast, and it is still generally moving towards the west, but only at 1 or 2 miles per hour. So now we have to look lower down in the atmosphere, somewhere right around, say, 700 millibars, 500 millibar, and we'll use the 500 millibar chart since it's our favorite layer in this case. So the thing that the big players on the field, as I like to say in my discussions here, is there are 2 ridges in place here. Okay, we got the primary steering influence ridge here that has been very well modeled on the European model. It is over the Western Gulf, over Mexico, over southern Texas. You're probably feeling some of the warmer temperatures there today. And let me actually turn this off so you can see. All right, so there's your ridge here. There's a weaker ridge here over the Windward Islands. Okay, and so you got a little H there. And then you got a trough up here. I mentioned this in today or yesterday's video for some of you. That is Thursday already. You have this smiley face trough to the north. And so what you're left with here is a break between the 2 ridges. And you might think that, well, David, the system should go north, right? Because it wants to follow the path of least resistance. Well, it only works if the system is deep. And the system is not deep right now. It is very shallow, rather shallow. The vortex only extends about maybe 700 millibars into the atmosphere. So it's not very deep at all. And so when we actually look at the 700 millibar layer, if it's even listed here, can we find the 700 millibar? There it is. So now what you end up seeing here at 700 millibars is that the ridge, there's a little bit of an extension to the ridge over here over southern Florida, and a ridge also over here to the northeast of the system. But in 500 millibar land, the ridge is over here. So what we end up seeing is an overall background flow easterly to the north of the system, helping to guide the system very slowly to the west right now, because the system is very shallow. Okay, so we got to understand that. So some of you might think, oh, it should be going north. There's a path of least resistance. It usually works that way, again, if the system's deep, but it's not. And so what ends up happening now in 60 hours, and this is an extremely, extremely delicate forecast. In fact, so delicate, we still do not know exactly where this is going to go. And I hate to be the person to say that, right? People rely on me all the time. That's why I have almost 60,000 subscribers. Almost 60,000. A lot of you rely on me very much, and I appreciate that, right? I'm A lot of people tell me I'm very accurate. I'm one of the most accurate forecasters out there. But I'm going to be like the National Hurricane Center, and I'm going to be on board with them. We don't know where this is going, and it's because, for one thing, and I'm going to put 3 bullet points up, not on screen, but I'm going to mark them down here. Number one, how aligned is the vortex, right? We talked about that, and it's not doing well. Okay, so we go to scenario number 2. Okay, will the vortex become better aligned sooner rather than later? If it's too late, it's too late. The system's going west anyways, right? Because what ends up happening here is this ridge builds to the north. And thirdly, okay, is how deep will the vortex get? There's a situation where it can get so deep that the system might go north anyways, regardless of how strong it is. So it's kind of like you finding the wrong spot, and we don't want that. And so what we have here on the Euro is watch what happens. Watch what happens. This ridge builds north of the system. So look at these wind barbs. See these wind barbs right here? You got flow. Let me get my arrow key. So you got wind here doing this. So you got flow doing this. So you got a little bit of a ridge here. You got a secondary ridge over here as well. So you got a little bit of an H here and a little bit of an H there as in high pressure. We also have another high pressure circulation over here, over far eastern Caribbean, over the Lesser Antilles. So the system really doesn't have anywhere to go except, well, pretty much due west at this point, because this up here is the primary steering feature. These 2 ridges. Of course, the system, whatever it feels most, is where it's going to go, right? That's how hurricanes work and how systems get steered by the environment. They just don't feel one layer. People still think that, oh, it feels one layer at a time, David. No. As the vortex gets deeper and more stacked, it feels the net flow, the average, right? So what we have here is a system that moves west. Yeah, it moves west, and then we'll see about this trough here. This is very difficult to model. Well, somewhat difficult in 5 days. If we look at prior model runs, this trough is going back and forth here. This is going to be another player on the field that gets involved and helps to steer this out of the Caribbean into the southwestern Atlantic eventually. Why is that? Well, because our steering flow changes in the deep layer as well. And you can see that here. So see, there's a trough that comes down. The Canadian model has indicated this quite well. Okay. And so we have some confidence in that. But if we look at just a model run ago, keep in mind this is 6 days out. One model run ago, we can go back here to 12Z. This trough was much further to the north. Okay. So you can see the vorticity here. There's your trough. We look at the 18Z run today, or just 6 hours later, this trough is a little deeper, allowing this ridge to move out of the way a little sooner and allowing the background southerly flow to kick in to scoot this out into the Bahamas. And so we have seen a little bit of a difference here, and it's about which one is more dominant. Is this trough going to be strong enough to pull this northward fast enough, or how far west is it going to go? Because if this ridge is a little further west, well, the system's going to be further west as well. And how strong will this ridge be in place? All right, so there's a lot of what ifs here that we don't know about, and I hate to be the person to say I don't know beyond 3 or 4 days out, because there is that level of uncertainty in the modeling that, that you could even ask a forecaster, like, it's not being resolved very well. Even so we get our aircraft out into this, it's just not helping. It really isn't very much. So we're going to need to watch this. We're really going to. And some of you are like, oh, David, it's following the GFS, so it's a little further east. Well, it's only been a couple of runs, and maybe the next set of runs, it's further west here. So we really got to pay attention to this one. We cannot ignore it. We cannot sleep on it just because it looks all yeah, yucky looking. It doesn't look very organized. Well, Humberto looked the same way, right? You guys remember Humberto, right? It looked like a skeletal like swirl out there in the Atlantic, and then poof, 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 thing became a Category 5 hurricane. Yes, that's how quick things can change here. So don't think that, oh, it's dying, David. It's not strong at all. All right. We knew this was going to happen. We knew this was going to happen. And that's just how it works this go around, right? So vertical wind shear now is going to depart the system. And you can see here that what I'm looking for here on a plot like this is these vectors. See these streamlines right here? See how they're going like this and they kind of go out like this, kind of going around the system like this. This is a vertical wind shear over the system, even so that, oh, there's not shear here or there's not shear here. I'm looking at the net flow, okay? So what I'm looking for here is this. We're looking for anticyclonic shear vectors moving away from the system, from this low pressure center, which indicates there's no vertical wind shear at all. So putting this into motion, this is very close to Jamaica. The shear is going to be very light over this area. And you can see the shear vectors are pretty much outflow in all quadrants here. There's not much restriction that I can see here preventing this thing from really taking off in about 3 to 4 to even 5 days. This is quite ideal for the system to be in for very quick strengthening. If we look at the 12Z model guidance here, which 18Z models can be very sketchy in some sense, so that's why we're here waiting for the 0Z models to come in. I am not going to use a GFS model tonight. That's an outlier. I'm not trusting that model right now. We're going to wait for our models, and we'll be looking at the Canadian here. Look at this vertical wind shear here. This is very, very light shear. Wait. Okay, that I'm looking at that right. That's 12Z. Okay. Now, this vertical wind shear here is very, very light in all quadrants. Yeah, this is not good at all. This is really, really bad for the system to be within, for it to really take full advantage. So that's what I'm really concerned about. And looking at the upper level winds here, I mean, from a meteorological perspective, I'm not a meteorologist, I'll be honest with you all, but I am a very advanced, highly skilled weather forecaster here. And the last time I saw something this favorable was with Dorian, was with not Milton, because models didn't handle with Milton very well. But I think it was with Dorian that I last saw a pattern like this, where the outflow was very well established in all quadrants. I mean, this is pretty significant here. This is strong. Okay, and what do we want for a system to strengthen? Well, we want it to breathe out in all quadrants, and that's what it looks like it's going to do here for us, unfortunately, in about 5 to 6 days or so. Looking at the 18Z run, not much different here, but the difference here is on this model, you get a little bit stronger background westerly flow hitting the system just enough to move this a little bit into Jamaica. The system still strengthens down to about 937 millibars, which is a Category 3, Category 4 in definition at this point. So, yeah, that's what we're looking at here. But the difference in the 12Z run is this little patch of wind here was further out to the northwest, allowing our system to drift a little bit, just a little bit, and stain over the waters a little bit longer for it to intensify. Actually, that's 932 millibars. So the 12Z had the Euro on the 12Z had it stronger than the 18Z run. But again, I'm not gonna just base my forecast off of one run, and we're gonna have to wait for multiple model runs to come in to make that decision. Now, we did get the Canadian model in, and this one is definitely a lot more bullish, and we can see this here if we play this through. The system really struggles and actually becomes more broad. This seems to meet realization right now with what we're seeing on satellite, really not faring too well. And again, this is the scary part of Melissa here. Melissa's kind of playing dead, if you will. System's dead, everybody. Looks like it's not going to do anything. I'm evil. I'm going to perk you and stuff. That's kind of what it's doing here. And so what ends up happening is the system really, when it's south of Jamaica, it really takes off. This son of a gun really takes off, and it gets very strong. In 5 days, we are looking at certainly a major hurricane here to the west of Jamaica and really close to Nicaragua and Honduras. This would be really bad for Honduras and Nicaragua because of very heavy rainfall, very large surf with this one, and even for Jamaica, getting some large waves and some heavy rainfall because you're getting that upslope flow out of the southwest. Or southeast, sorry. But look at how big this thing is. I mean, I can't even see red in that. That's a black dot. That is a very compact system. Okay. And you can even see the low-level winds here. This is a really big system. This is very strong here in about 6 days or so as it moves right over Cuba. This is still pretty far to the west than what the European model is showing and then what the ICON model is showing. So this is to be taken into consideration here. And man, this, look how close this gets to Florida and over the Bahamas. This would be really bad. Okay, just place bets on that. This would be a really bad scenario if this actually pans out with what the Canadian model is showing. And that's 0Z model run tonight. So now if we go back and look at the Euro one more time, with that scenario, you can see very similar, only again, it's further to the east here. And then we will have to really watch with how it interacts with the trough off the east coast here, because this could swing in and bring a lot of rainfall and some strong winds into the northeast. So something that we will have to be considerate about with some of the Ensemble members, even bringing this extremely close to the northeast coast in we don't know when, but beyond the 7 to 10 day, beyond the 10-day forecast for sure. So we're not done with this. We're just getting started. And I'm afraid that not only this is going to be historic potentially, but this is going to rack up a lot of ace points. And this is going to be a system that does not last for 2 or 3 days and it's done. I think this is going to last for a full 10 plus days, unfortunately. As this gets, again, you even see the 10-day mark right here. There's your circulation hitting Nova Scotia in about 10 days on the 12Z Euro model. So that would be the first day of November, and it's only the 22nd of October right now. So we have a long way to go before this system is done. And I'll be glad it's done because I have a lot. I got to get planning for winter. I got to get my weather maps all made for you all. And get that all prepped, but that's being held off because of this stupid system. Stupid Melissa. Everybody say stupid Melissa in the chat if you want, because this thing is very annoying at all. 2 days ago, I think it was like 2 or 3 days ago, we were not talking about a Category 5 hurricane. Now we're talking about a Category 5 hurricane. Yeah, that's how things can change in a blink of an eye. Really, they can just shift very quickly. Okay, so let's take a look now at our hurricane models. And I wanted to look at the 12Z. I know I included that in my video earlier today, but what I did not include is beyond the 3-day forecast because the model was currently in its rendering cycle. So we were not able to show you that in the video. But we're going to run it all one by one here. First with the HWRF model. And this is a hurricane weather research forecasting model. And then we'll be looking at the HAFS, the HMON, all of our reliable hurricane models, as I promised in my post. So the 12Z HWRF model, I mean, this is very close to the eastern tip of Jamaica. And this would be really bad because you get orographic flow out of the north here. This is going to really squeeze out a lot of moisture over these taller mountains here of Jamaica. And this would lead to considerable flash flooding, landslides, debris flows, that sort of thing. Very heavy rainfall and flooding, water spouts, maybe even a tornado or two moving onshore here over far eastern Haiti in the Haitian Peninsula of Hispaniola. So this is going to be a mighty, mighty rain producer. Regardless of if there will or won't be wind for your location, there could be some significant winds with some of these rain bands that move onshore, because there could be water spouts, and water spouts have winds with them. And so keep that in mind. But this is going to be a very, very big rain producer, okay, on the HWRF model. But models handle this very differently. And so what we end up seeing here is a very strong system on the HWRF model with winds that are around 115 to about 125 miles an hour. And look at this. This just does not move at all. Really, really slows down. And a slowing system, folks, you can't get anything worse than a stalling system like this over a couple of days of time. In fact, some portions here of eastern Cuba, this is Saturday night, so that is, and then into Sunday, that's day 2, and this is day 3 perhaps, and it is still raining over eastern Cuba. 3 days of constant heavy rainfall. Some of the rainfall rates could exceed 1.5 inches to 2 inches an hour. And I mean, I cannot, I mean, I would not be surprised if we have some big time flooding here. Some of which could be once in a blue moon for some locations here, because the system moving this slow, man, you get some very heavy rainfall. You're talking about some big time problems. And there is the eye wall as it is offshore, and that eye wall moves over eastern Cuba here as a formidable hurricane still, with very, very, very heavy rainfall. And look at some of these bands here. That's off the charts. That would be rainfall rates greater than perhaps maybe about 1.5 inches to 3 inches an hour. So there would be some considerable flash flooding with some of those bands. So that's the HWRF model. Let's take a look here at another model. Let's look at the HMON model, which stands for Hurricane Meso, something with the O and then the N. That's what I don't know about. I know the H stands for hurricane. And let's go back here and look at the 12Z. Actually, you know what? Shoot, I forgot to show you all the 18Z on the HWRF to compare that. So this is the 18Z run. This is the 12Z run. So this is further southeast. This is over here, and now it's over here. We'll see with what the pair of 0Z models show tonight. If this is closer to the coast, excuse me, or if this has shifted further to the east or west. But this model has this very strong, and again, really, really close to the coast here. Between the two land masses, actually 3 in this case, you got the Haitian Peninsula, you got Jamaica, and then of course you got eastern tip of Cuba. Man, kind of like the Bermuda Triangle, right? You can kind of put a triangle right over these land masses, and that's what you get. And man, that's one heck of a strong system on this. This would be a Category 4 hurricane, even stronger than that, possibly getting to a mid to high-end Category 4 hurricane, really, really close to Jamaica, and then really just sitting, just not moving at all in this general area. In fact, when it gets over here, let's just go to 18Z Sunday. So it's over here, 18Z Sunday. Let's go to 18Z Monday, and it hasn't moved very much at all. This is very, very slow, very bad for Jamaica, very bad for the Haitian Peninsula of Haiti and Hispaniola, and then, man, really bad for eastern Cuba if this actually verifies. I really, really pray that this does not verify, because this would be really devastating. Yes, you wouldn't get hurricane force winds, but you would get tropical storm force winds here in on the southern, the eastern tip of Jamaica and the western tip here of Cuba. But the rainfall, man, can't say it enough. The rainfall would be the bigger story of this system than the winds itself. unless the eye wall moved onshore of Jamaica or one of the land masses. So that's that. Let's look at the HMON now, and we're just going to skip on through to the 18Z while we're waiting for our 0Z model to finish rendering. Then we'll provide that in today's update, or tonight's update. So the HMON model has a different scenario. This one is south of Jamaica. This would be also really bad because, well, Jamaica is smothered in heavy rainfall. Some of these would contain some water spouts, maybe some tornadoes moving onshore here on the southern coast of Jamaica. Probably not so much on the leeward side because you would get, well, tornadoes don't like mountainous terrain here. So a tornado threat does not look very much likely on the northern end of Jamaica in this situation, but anything coming onshore like this, you would have water spouts, and some of those water spouts could be quite destructive, could really blow down a lot of trees, power lines, extensive damage. And then, of course, here is your very powerful eye wall with Melissa, and that's down to 933 millibars. This continues on this model for the next 126 hours as a very strong hurricane here with winds, again, around a Category 4, about 130, 125, 135-ish miles an hour on this particular model. But there are other models that go even much higher than the two that I showed you, and that's coming from the HAFS A model. We'll look at the 18Z first. We'll be providing the 0Z here in a little bit. So the 18Z model forecast, I don't think you all, actually, yeah. The 18Z on the HAFS A really blows this system up very, very quickly. And actually, this is reality, right? Right? You know what? Pressures actually are really accurate on the HAFS A here. So this would be something to take into consideration. There's your low, very broad. That's what we're pretty much seeing on our aircraft recon data. So that's where the system actually is here. And then it tries to get better organized by tomorrow afternoon here. You can see another area of vorticity here, maybe something down here. So maybe some recenter or relocations of the center kind of orbiting around a parent center here perhaps. And then the system really consolidates. Oops, spoiler alert on that. So you can see right here, and by Friday, it really gets its act together. And by Saturday, it really takes off. This is when an inner core structure is supposedly to form, all right, based on the simulated forecast here from the HAFS A. And then it really takes off, man. This really, really fires up very quickly. By Monday morning, this is down to 902 millibars. 902 millibars with maximum winds here of 150 knots. 150 knots, that's like 170, 180 miles an hour. That would be very close to historic records here for this part of the Caribbean. And this continues to be a very intense hurricane thereafter. Now, if you want it to be more intense, go and look at the 12Z HAFS A model, and this is even more significant here. Forecasting, actually not as significant, but the pressures are about just as low. But that's actually from the HAFS B model. If we look at the HAFS B, this is where, oops, spoiler alert there. Let's look at the 12Z forecast. This is what got everybody's attention. This is, I mean, I saw it all over social media, and this really gets intense right here. So now I want to stop for a second and discuss about this, okay? And I'm not saying anybody's wrong out there. I'm not trying to be the better of who all in this type of situation, but it is very, very hard. In my historical records of forecasting tropical systems like this, it is extremely difficult to get a system this intense, all right? It is theoretically possible because we have extremely high upper ocean heat content. I get that. Sea surface temperatures are 31 Celsius. They're very, very warm in the upper 80 echelon. We have a lot of deep layer moisture. we look at our moisture in this present time, very moist atmosphere. So I get that. I really do. But it is extremely, extremely too soon to say. And it's, again, based on now and forecasting the future. Okay. I'll admit, I posted about it. Excuse me. Just had dinner. Not trying to burp here on stream. But we got to watch this. We really do, because this was a threatening message. And I was like looking at this. I'm like, you got to be kidding me. That's what I even said on X. If we actually go to X really quickly, I said, you got to be kidding me. Literally, kind of some of the context that I don't usually use very often. Right here, you have to be kidding me, HWRF. It literally was showing that, and I was like, really? Come on. You're not predicting a category 5 on a historical record, because this is climax. This is a 173 knot storm. This is over 200 miles an hour. Sustained wind at the surface. That is getting up there in historical records, and it is very, very difficult. For one thing, very difficult to forecast that intense of a hurricane that far into the future. And secondly, everything has to be nearly optimal and pristine. Vertical wind shear needs to be very, very light. And if we actually take a sounding on this forecast model, vertical wind shear here is 7 knots. Actually, let me make sure I got that. You have to get this as good as we can. There we go. Yeah, see, vertical wind shear here is 7 knots. So there is even a little bit of vertical wind shear here for this system to really thrive within. If we go back, though, I want to see if the shear is even lighter, because you need the shear to be generally under 5 knots for a system to be this intense. Oh, yeah, right here, there is no vertical wind shear whatsoever in the deep layer of the atmosphere. There is nothing at all on this model showing any vertical wind shear at all. And if there is any, the maximum shear is about 5 knots. So this is as ideal, as pristine of an environment you could actually get here. And if we look at one more here, oops, forgot, I just realized I did not show the whole sounding. 3 knots here. So this is probably not any vertical wind shear at all. This is pretty much under 2 or 3 knots. And that is how you get one of the strongest hurricanes ever on record in the Caribbean, because the vertical wind shear, it has to be very light. It has to be this light to get something like that, because, well, if there's no vertical wind shear at all, your vortex is going to be extremely intense. It's going to be extremely vertically aligned. And there's not going to be any little tilt with it at all. And that's going to allow a system to be this intense. Okay. And actually, there's a cool tool that Tropical Tidbits even provides here. And you can see, like, when I saw this, and again, this to me is like bonkers. Like, you can even see it looks like a tornado. Literally, that is a classic signature of a violent, historic, all-time record-breaking hurricane in the south or in the northwestern Caribbean. And you can even see it here. And actually, I think we can do a cross-sector our own here really quickly before we show you the latest model runs. Can I do it? Shoot. I know there's a way. Oh, here we go. Submit. So, HWRF. Okay, that's what we wanted. We wanted the HWRF forecast. See here. Yeah, see, this is what your vortex looks like. And man, 100 millibars. This is a very, very deep vortex. Very deep indeed. You have winds that are 64 knots, hurricane force, all the way up to 47,000 feet. Very intense eye wall here. And by the way, this is not a mountain. That's the surface pressure. And because the model interprets the lower the lowest pressure as being like a mountain, like because if you go higher up, the pressure drops. So this is a very, very strong, very symmetrical, very well vertically aligned vortex. In fact, if I draw a straight line from the exact center, yeah, this is extremely, extremely vertically aligned. There is no tilt at all with this. And that is why you have a system that is extremely, extremely, extremely strong. Okay. That's what we're dealing with there on that run. See what the latest hurricane models show now. Let's look at the 0Z models that are coming in right now at the moment. And this is actually stronger. And this is further to the east. Interesting. Further to the east, but also okay, not by much. It's a little further southeast, probably to align better with what we're seeing right now with our system. So we're going to see where this takes the system as this is coming in. So that's the HWRF model. Look at the HMON model because that's a little further in. So there have been some big shifts with this with the trends in the last couple of runs. Yeah, so this has shifted continuously off to the east right now. So our HMON model a little closer to the GFS here near the Haitian Peninsula now, not really closer to Jamaica on this model run, which I think is being underdone. Yeah, this is being underdone because, of course, we're not seeing winds this strong. So this is probably to throw out because, for one thing, the pressure is not 995 millibars. Yeah, it's not 994 millibars. We are not seeing near hurricane force winds on the northern side. So I would not trust this model because it is strong biased. We clearly looked at our recon data, and we do not have that patch of wind on the northern side. So the HMON may be overdoing this a little bit. A little bit. Just a little too much. So we'll see what the HAFS A shows. So the HAFS A is out to 2 days. So this is a little stronger. Actually, this is the strongest model run of yet. And it is right with that HWRF model. So the HWRF model, actually, HWRF hasn't rendered that far. So the furthest we only have right now is on the HAFS A. Shows this becoming a hurricane in 2 days. 2 days. And it seems to be a bit more realistic here. Yeah, it seems to resolve things a little bit better. Yeah, it seems to do quite well with it. So I think the HAFS A is, we're going to need to really watch how strong this actually gets on the HAFS A. Look at the HAFS B. The HAFS B is a little further in. And what do you know? We have a much stronger system here. This is moving around, though. So you can see there is Jamaica for reference. That's the 12Z run. Here is the 18Z run, much further, very much an outlier at this point. Here is the latest run, much closer to Jamaica, which means it's a little faster. There's the island of Jamaica. There is the Haitian Peninsula, and this is much stronger, way stronger, probably the strongest of yet on the HAFS B model. So we are going to need to really watch this very carefully because this gets very, very close, and it moves very slow, very slow. Any questions, anybody? Any questions? We're going to watch the models as they come in tonight. I'm curious of what the European model is showing, though. By the way, if you have not subscribed to the channel, if you haven't been here before and you do like my discussions, the detail that I put into my discussions here, please subscribe to the channel, hit that like button, share this video with your family and friends on social media, and also leave a like if you haven't already. That isn't happening, a couple of people said. Sub 880 millibar incoming. Yeah, I think the HAFS B is a little too aggressive. We'll see what the HAFS A shows once it gets this far out. But this is 60 hours out, okay? 60 hours out. Excuse me. And the NHC does have a hurricane here, so I think it is a little too bullish. I think it is. But the HAFS B has not done too bad this hurricane season, so it is very much possible that it recovers really quickly. It really might. It certainly can. So what circumstances would take it into the Gulf or Houston? It's not going to go into the Gulf or Houston. There's no way that's happening. If it did, then I literally, I'd be like, how? How is it going into the Gulf like that? It's just not going to. I'm very concerned that it gets very close to Jamaica. I don't blame you. I really don't blame you. This is really bad. I mean, Jamaica is not out of the woods. So is the Haitian Peninsula, honestly. How close does it get to Florida, please? Let's go to here and go to the Canadian. It gets pretty close to the Florida coast. And for that, let's go to the Bahamas because Florida is on the top side of that image. So as we look at the Canadian model, by the way, that's a 85 or so mile an hour hurricane. You know what? That is really bad. Miami actually on this, I'm not putting, the Canadian is a little too far west in my opinion. I really think it is. But if this scenario pans out, yeah, Miami, you're going to get a lot of wind out of this system and perhaps probably a lot of rainfall as well. Wind gusts would get close to 100 miles an hour. That would be really bad for Miami, Florida, for the northern Bahamas. That actually comes true. Oh, wait. What the heck? Did this just crash on me? Come on. There we go. That was really funny. The thing bugged out. But yeah, this would be a really, really bad situation. Really bad. I think the system has a potential of 910, 930. Okay. What's up? In Miami here. So some of you are watching from Miami, Florida. This is going to get a lot of people's attention in Florida. I wouldn't be surprised because, of course, we're dealing with a system that does kind of get a little too close. So let's go back to the tropical tidbit site. Let's see. Oh my gosh. This thing is going west and south of Jamaica. But the tall mountains here, we got to keep in mind now, if this gets pretty darn close to Jamaica, the tall mountains could prevent this from getting any stronger due to frictional slowing of the winds. All right. And even maybe a little bit of drier air because of the sinking motion that happens on the leeward side of the mountain range here of Jamaica. So that could, that might actually help destroy the system a little bit. Not destroy it completely, but like at least not allow it to intensify as quickly as what it can do. And I wanted to show you the topography here of Jamaica really quickly with what I mean by that. Because Jamaica, there are tall mountains. Actually, Jamaica's not really mountainous like I think. Okay, it's this part of Jamaica that is really mountainous. Okay. Yeah, that has 3,000 foot level mountains. Oh, actually, this is 3,000 foot mountain side here. So, yeah, actually, that could help lead to some frictional slowing of the winds if it's too close. I think it would be too far away from Jamaica to really have any detrimental impact here. Yeah, that's a 932 millibar system. Strongest of yet. Literally the strongest output that we have had thus far, actually. Nothing beats this at all. This is the 932 millibar system. 932 millibar. And it is actually, in the recent frame, it's actually headed this way. So it's actually moving pretty much to the west-southwest. So that is the strongest model of yet on this system. See what the HWRF A is showing? HWRF A is further south than the HWRF B. Actually, it's closer. Man, it's actually closer than the 18Z run. It is actually further west. Well, it's further north, but it is not really trending really close here to the Haitian Peninsula. And again, this is the strongest model run of yet at this present time. Actually, not the strongest. The strongest was last night's 0Z run. We're going to wait for the European model. Who's all excited for the European model to render tonight? Let me know in chat. I am sure everybody's excited, because that will be our ultimate decider. Is the GFS the winner in all of this? Because I'll tell you right now, the GFS is too strong. Still too strong here. I mean, look, it has winds. It literally has winds. It literally has winds that are, yeah, it has winds too strong. I just don't think it's happening. I think the GFS is crazy in that sense, and it really, I mean, it barely becomes a hurricane. I mean, that actually is only a low-end tropical storm on the GFS, so that is a huge outlier. Actually, the GFS does not indicate any strengthening at all. But only time will tell, right? That's why we have hurricane models, for a reason. GFS is practically off the table for right now. GFS in Lundoland, yeah. Yeah, that's... Yeah, I mean, it is... I don't know why the GFS has not corrected. Ivan, Mark Sedeth on YouTube, go follow him if you guys want, at hurricanetrack.com. Really good guy. I actually know him in a way. We have talked before, and he's even saying that, is the GFS model broken? Why in the heck has it not leaped towards the other models? I mean, it is a huge outlier. And so until we see the majority of the models trend towards the GFS model is like a kiss goodbye. That's why I'm not using it tonight. I'm using the Euro, the Canadian, and the Hurricane models. Actually, let's see what the Icon model is showing too. You see, the Icon model is interesting. The Icon model wants it really close to the Haitian Peninsula. Interesting. Let's see with what the artificial intelligence model shows though. Yeah, see, this is rendering, and it is south of Jamaica. It is south of Jamaica. You guys can see that, right? Can you guys see that? It is south of Jamaica. So that proves my point. And the AFIS, artificial intelligence, the machine learning technology model, really has a strong, well, it doesn't look strong, but it is very strong. We got to understand that this is not a high resolution model, so this would be a major hurricane. And it really gets strong. Look at that, right over Bermuda in about 210 hours as a strong tropical storm and a hurricane, if that. And pressures on that system get pretty low. And this has trended stronger too in recent model runs. Oh yeah, this has trended definitely stronger. A little bit. And it's a little further west in this model run. So that's interesting. Let's see what the Ensemble shows. I'll use the 18Z run for this one. Oh, wait, hold on. There we go. Yeah, a lot of these members are well to the west. And then looking at the European Ensemble forecast. And yeah, this is pretty bad. Very bad. Look at some of the members are even going sub 900 on this. So boy, there's a big ceiling on this. Very significant ceiling. So oh man, we got to watch this one. We really do. Man, yeah, there we go. That's what I was hoping for. We got our European model rendering. Here we go. What does it show? What does it show? It still shows a system stalling out. It does not show it moving. It is further south and a bit further to the west from its 18Z model run. It is, yeah, it's pretty much in the same area than the 12Z model run. This is going to be interesting. So there has not been changes on the Euro in the first 40 hours. Let's go back and look at HAFS A again. Okay, HAFS A is down to 945. Man, that's a big drop in pressure in 3 hours. It is dropping about 15 millibars per 3 hours. So that is explosive. In terms of strengthening, HAFS B, let's go to that. So there you have it. Okay, so it looks like we are seeing some restriction to the flow coming into the system. That's why the HAFS B does not show the system. It's stronger than the 18Z run for sure, but it is not as strong. Oh, no, it is stronger. Oh, hold on. Is it stronger? Yeah, it's about as strong. Yeah, it is stronger. What category? This would be a category 4. This would definitely be a category 4. But I'm just, I am really generous. There's so much uncertainty with the intensity and track forecast that I am not convinced. I am not convinced that this is going to be a category 4. I really don't. I'll let you guys know once all the models are done rendering here. All of the HAFS models. But there is something that tells me that, yes, this could become a Cat 5 for sure. But the other half of me tells me that it's not. And that's because of the track forecast. Hold on, let me take this. It's getting a little warm in here. Um, it's that track forecast I cannot get out of my head. Um, I really wish we had a set in stone track forecast, and then I would be able to predict this a lot better. But I just don't have a solidity answer on how strong this is exactly going to get. Just because we just don't know where this is going to go. And man, the HWRF. Dude, the HWRF has nothing on the system. Barely a tropical storm in about 42 hours. See, there's that level of uncertainty. You can clearly see it. There's not a set in stone intensity forecast. The HMON, what does the HMON show? Yeah, the HMON just has it sitting there. So likes this general area right over here, it seems like. The HWRF and the HMON want it over here, it seems like. See if that actually verifies. But that really spins up in about 90 hours. The HWRF, we're not that far in yet. See the HAFS B. Still no progression on that model yet. Interesting. There's more shear on this. Little bit more vertical wind shear. I can tell. There's a little bit of asymmetry to the moisture plot here. Some drier air even. That's to be expected in about 3 days. The shear doesn't back off entirely until about 3.5 to 4 days. Two AM advisory is out. They're probably lowered the intensity. I would probably place bets on that. No, they did not. Interesting. Okay. They did not lower the intensity. It is still at 50 miles an hour. So maybe they did find wind that was that strong. Or maybe they see some recovery. Okay. Okay, I see. Okay, I don't see the... Man, it is hard to tell if the circulation is over there or what. Looks like a new burst of deep convection really exploded here now. And we'll watch that. That's a little bit closer to the center, actually. So we'll monitor that over the next 30 to 45 minutes while we're watching our European model render. Oh, stronger? It is. Wow. It is stronger. Wow, okay. Not as strong as the 12Z output, but it is further south at the same time. That is not good. Not good at all. Still the European model refusing to agree with the GFS model. Still, that is a big problem. And this would be a hurricane in about 3.5 days. The question is, how much further west will this go? Again, it really is going to depend on this system. At this point, the system decides where it wants to go. Models don't decide where it's going to go. So that is the Canadian and the European model are quite close. Man, and I'll tell you guys what right now. I have never been this frustrated when it comes to forecasting. I mean, this is getting too much. This is getting too much with the GFS really an outlier. I mean, can they just shut down the model? Like literally just shut down the model and not turn it back on for a while? Because literally it is terrible, doing terrible at this storm. But I do love you guys. I'm glad you guys are here watching me. I know it's late. I did have work tonight, so that's why I had to I couldn't go live when I wanted to. Had to eat dinner and kind of get that all out of the way, so I'm able to stream for you guys. So yeah. Wow, pressure on this is dropping very quickly. And we're at 81 hours out. And this is moving west-southwest, moving pretty much this way. How do I know it's moving this way? Follow the island. Follow the island right here of Jamaica. If the island is moving this way, the system is moving west-southwest. If the island is moving this way on the map, the system is moving southwest. So you can see the island moving generally that way, which tells us our system is moving this way. That's not what we want, man. If I am telling you, if this gets into the Western Caribbean, west of Jamaica, this has a very, very high ceiling. A very, 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 very high ceiling. Something that could favor, and I'm going to say it, and you guys will probably make fun of me, could favor a Wilma intensity. Could favor Wilma. I hate to be the bearer of bad news, but if this gets like over here somewhere off the map here, I know you can see my mouse over here. Oops. Maybe that's why, because I didn't have the right scene in place. But if it gets way over here, this system is going to be very intense. It could get very intense. Something, again, in the echelon of well into category 5 intensity. And you saw it from the HAFS earlier, and I could even show you the breakdown of miles per hour on that system. This is the 12Z output from earlier. Yeah, there's a solid donut here of 230 mile an hour wind gusts. Yeah, 230 mile an hour wind gusts on that beast. Yeah. Now you can say, holy crap, that is strong. Yeah, you can see here's Nicaragua and Honduras. You can see the state line right there. Yeah. So if it goes west of Jamaica, it is going to be much stronger. If it goes east of Jamaica, it's not going to be as strong because a little bit of vertical wind shear and some land interaction, some mountainous terrain that can disrupt the flow into the system. But it would still probably become a major hurricane, more likely a category 3 or a high-end category 2. But if it goes west of Jamaica, all bets are off. All bets are off. So the European model has not rendered. Wind gusts seem to always go ahead of schedule. And the European model wants this to peak at 180 mile an hour winds. 180 mile an hour winds. Whoa, what in the heck is that up there? I hope you guys did not see that on the Euro. What is the European smoking? What is the European model smoking? Oh my gosh. literally in about 7 days, it wants its own hurricane off the eastern seaboard. That would be a big system if that verified. That would be, though, a subtropical because of the frontal features that are involved. Yeah, that has definitely frontal features. Steam jet on the backside. Wow. Hopefully that does not verify. That's only one model run, so I'm not putting any bets on that. But yikes, the European model is very aggressive in this forecast. Showing the system clipping. Man, it is, wow. It is exactly the same thing with what the 12Z showed. And actually the strongest run ever. Wow. You guys, you want to know how strong the European model peaks this at? You guys want to know how strong? You guys do not want to know how strong. From a conservative model, typically. Well, the European model wants to peak this at 190 mile an hour wind gusts. 190 mile an hour wind gusts. Just right, pretty much on top of Jamaica and just to the north of Jamaica. That is bad. That is bad. And you could even see it here. I sure hope it can. Well, this is in knots, by the way, so knots are not going to give us a good handle on this, but 165 knot wind gusts on this system. We go to, let's go to miles per hour to knots. That's going to be about 190 something, I bet you. 165 knots. Oh, wait. Kilometers an hour. What the heck? Knots. There we go. Miles per hour. So 165 knots is about 190 miles an hour. So we're looking at a 190 mile an hour maximum peak intensity, perhaps, on this system. So that's from the European model. Oh my gosh, Euro. Holy moly. Dude, this 920 millibars on the Euro. 920 millibars on the European model. Just north of Jamaica. Wow, dude, this thing really takes off. Man, that thing explodes. That is a very strong hurricane still. 945 millibars. Right over to the southeastern Bahamas. Wow, this would be... From the Euro, you're seeing it from the Euro. Well, more than anything, the GFS is like the Euro, but yeah, you know what I mean. So there is weather models that actually shows it even in more high resolution. Let's see if I can, because sometimes certain websites don't extrapolate the pressure as well. So I want to see if they... Okay, this is what we want. Will it give us the pressure? Shoot. No. It's not going to give us a pressure. It's not going to give us a pressure. So what we're going to have to do is zoom out and look for Central America and go over to... Hoping... Here we go. Because on here it shows millibars, and usually... Wait. Oh, this is a 0Z run. Good. Okay. Okay, it's not that far out here, but it shows this down to 929 millibars. Even so, here, oh no, it is okay. It does show it. It is the same. Sometimes, depending on the situation, sometimes weather belt underdoes the viewed pressure versus the different sites. But the European model has this down to 920, 921 millibars. And that is bullish. That is extremely, extremely bullish. Sorry if you hear me go like that. Hopefully I'm not getting sick. Hopefully I'm not getting sick at all. I don't think I am, but I just have a really bad scratchy throat. But yeah, this is really, really, really concerning. Man. Rainfall over the area. 1,600 millimeters. Wow, that's a lot of rain. That's a lot of rainfall. Yeah, that's not good. Not good at all. Okay. 9-10 millibars on the HAFS A model. And we are at a category 5. We're back at it again on this model with category 5 intensity. Wow. So, even so, if it's this close to Jamaica, it still explosively intensifies. This is a 0Z model right now, by the way. 0Z model. Peak intensity 151 knots. So that's like 175, 180 miles an hour. Yeah, rain in millimeters, very significant. David, look at the HAFS B now. Someone yelled at me to look at the HAFS B. That's not good. Are you yelling at me? Don't yell at me. No, I'm just kidding. Let's see. Am I seeing that right? You guys, this is the 0Z model run, right? Or is this a 12Z? I want you guys to help me out. I want to make sure we're looking at the right model run. That's a 0Z? No. Oh my gosh. We're back at it again. We're back at it again. Dude, this is the most intense model run. The 12Z model run had this at 989.5 millibars. This one, not as strong with the winds, but the pressure is down, which means the maximum winds on this thing, 174 knots based on the pressure. Based on the central pressure, 174 knots at the surface. This is the HAFS B model. Okay, there's two hurricane models that are new that came out a few years ago. The HAFS A model, the HAFS B, which stands for Hurricane Analysis Forecasting System, B. So the B is just like, it's like a version, right? You could have HAFS A, HAFS B, HAFS C, HAFS D, HAFS E. They're just different versions, okay? But they mean the same thing. So there's kind of like one big model split into two, in other words. So that is what we're seeing right here. This thing, dude, oh my gosh. This thing takes off. It's like, it just takes off. Wow, man. Oh, man, that's bad. That is pretty bad. Even this one. Even the HMON model. The HMON model wants us down to 940 millibars. That is, I think, a little too high given the European model. This would still show a major hurricane. By the way, 115 knots. That's about a Category 4 hurricane. Yes, this would be a Category 4 hurricane. So we are in the books of a Category 4 hurricane, even on the HMON model. The HWRF, let's see what the HWRF is showing. I don't know about that one. I don't know about that one. In 69 hours. Literally, I don't know about that. Wow. Okay, so man, this is bad. This is bad. I think this would be the peak. Wow, it's even showing an eyewall replacement cycle on this one. Which don't take that into consideration because it is very hard to predict eyewall replacement cycles. But you can see definitely an outer eyewall trying to develop with the inner eyewall being the prominent one. But on the visible satellite or on the simulated IR satellite, though, that is very dominant, though. Yep. So it's weakening a little bit, but not by much. Still 888 millibars. 888 millibars. And yeah, you can even see it right here, a secondary wind maximum trying to set up around. So that is definitely forecasting an eyewall replacement cycle, which is quite amazing for a hurricane model to show that. They're saying I'm fear-mongering? No, I don't think so. I don't think so. I don't think it's going to be this strong. I'm on edge about it. I'm still on edge. But it has been really, really strong. Not as strong as he had on the 12Z model. Okay, I'll tell you that right now. It's not as strong as that, but still it is very, very strong. It is drifting extremely slowly to the northwest. And my gosh, Puerto Rico. I feel bad for not Puerto Rico. I feel very bad for Jamaica here. We're just getting hit with rain. The season's timing of the hurricane season is odd. Not really. We had a pretty good burst of activity in early October. It's very hard to say on if Melissa's gonna follow where the HAFS A and the HAFS B models are. It is worth noting the European model has this solution, though. It is on the solution. So there is some fidelity with the hurricane models tonight because the European model still seems to be trending in that general direction. Oh, yeah, look at this, you guys. I don't know if you guys can see that. Can you guys see that just fine? I hope you all can. That's what I was waiting for. That's why I use different maps in this type of situation. Okay, yeah, I don't have the scene set up. I want to get a little closer if I can zoom in. Yeah, there we go. I don't know if you all can see that. That's 918 millibars. 918 millibars on the European model. Right here, you can even see it. Right here, 918.3 millibars in 162 hours. Right where I thought it would be most intense. Right to the north there of Jamaica. And again, you can see that's 918 millibars. So I don't know if you guys can see that, but that's what the European model is illustrating. Down to 918 millibars. That's very strong. That's very strong. So, yeah, the European model wants this down to 918 millibars. That's very low. That's very low for a conservative model, for a conservative type model to show that. Man, this is going to be a disaster. Okay, I want to see what the HAFS A is showing. What the HAFS A is currently showing for us. Interesting, the wind field expands. No eyewall replacement cycle on this. Or maybe an eyewall merger. Pressure does get down below. Wow, it actually drops below 900 millibars. So that would be a sub 900 millibar system on both of the HAFS models. Again, I don't like to hype up stuff. I am not falling for this just yet. I am not falling for it. I need to see more consistency. After seeing the 18Z, well, the 18Z was pretty coherent on the HAFS A, but not the HAFS B. So I'm a little on edge about this, but it is doable because of the upper ocean heat content, very high. Yeah, very high upper ocean heat content, very warm sea surface temperatures. That's a guarantee with this. And very little vertical wind shear. So this is in the realm of possibility. I am not surprised by it. I am not. Yeah, vertical wind shear is 6 knots on this system. 6 knots. 6 knots. So there's your answer. There is your truthful answer. I really just pray for you guys. I really do. Oh. This is not good. Not good at all. Anything below 920 millibars is going to destroy almost everything. Yeah, for sure. Yeah, I'm definitely praying for Jamaica on this one because honestly, it's not about the wind at this point. Again, look at, there's not a whole lot of wind over Jamaica. There will probably be some higher winds definitely than what this is showing, especially in the higher elevations. But look at the rain. Look at the rain that you all are going to be facing. Like literally, if this scenario ends up happening, water spouts, tornadoes, very heavy rainfall, landslides, that sort of thing. I mean, wind is not your enemy here. It really is not the biggest problem. The rainfall is going to be your enemy instead. Unless the eye wall, literally touches Jamaica, then you're really screwed. Then you could literally say, I'm in trouble, David. But the good news is the center is not moving over Jamaica on this latest run. And it is going to be intense. What's up, Logan? How are you doing? Welcome back, bud. How are you doing? Actually, let's see if we can bring Logan on. Actually, he is going to school for meteorology. I don't know if you're available, Logan. I want to hear your thoughts on this system. So if you're available, I don't mind you joining for maybe a few minutes. Good morning on the East Coast, Teresa. All right. Yeah. He's going to school for meteorology. He's going to be on in just a second. And I want to hear his thoughts on this. Because this is really, really bad. I mean, the HAFS-B is definitely a lot worse than the last model run, for sure. But not as bad as the 12Z model run. But look at how slow this thing is moving. It is not moving very fast. Literally, it is not moving much. Dude, the storm is literally struggling to survive right now. Well, I understand that, but that doesn't mean it's going to stay that way. The euro, let's look at the euro again. Yes. What's up, Logan? How are you doing? You there?
Hello?
Hey there.
Oh, there we go. I had to switch over to my headphones. So you wanted my thoughts on this storm?
Yeah, I want to hear your thoughts because the halves A and the halves B are really aggressive. Seems like the HMON is also on board, but much further to the northeast.
I hate to say it, but I can see what the HAFS models are doing. That's actually what I've been most concerned about because of the area where the storm is set up. Given the steering currents and the pattern of this environment, I honestly could see it going any which way, but I think, especially considering the fact that the HAPS models are very consistent with the outputs of category fives going to the south and then turning slightly to the north like they've been, I see that as a possibility, and it's got me deeply concerned.
Makes sense. Makes sense.
Mm-hmm. Yeah, kind of like a Wilma or Mitch situation.
Yeah.
Maybe even Allen, which is more similarly related to the HAPS-B model. Because I know that showed 200 knots or close to 200 knots earlier on the past 2 days, if I remember correctly.
Very close. Yeah. All right.
Yeah, one of the in-betweens suggested 195 knots or 225 miles an hour, which would be record-breaking.
Oh, yes. Oh, yes, for sure. All right.
Not even just in the Atlantic alone.
Oh, easy. Yeah, it would be a new record set. Outside the Dorian.
Worldwide.
Yeah. So I wanted to show you everyone here that's watching this live WRF model, man, right in the middle of Jamaica. That's the worst case scenario you could ever dreadful hearing of. I do not believe in this right now. I'm not taking the HWRF seriously at all. I think this is going to either be to the north, to the east of Jamaica. We might see turns that do this like we're seeing, and then it kind of comes around like that. That's what the European model is thinking, that it slows down here and turns back to the west and then comes right over just off the coast of the western tip of Jamaica. But the WRF model, I am not believing this just yet. This is one, a little too weak on approach to Jamaica, and secondly, it shows literally the system trying to intensify in the middle of Jamaica, which doesn't make sense. It really doesn't, because of the tall mountainous terrain. So,
hey David, if I may point out something else too, the longer that this storm stays weaker, the more likely it is to go south instead of north, like the GFS, because it's expecting it to blow up quicker. So the longer it stays weak like this, the more dangerous this storm could be.
Oh my goodness. And that's a
I mean, that happened. I mean, that happened with air, and the longer it stayed south, the further west it went towards the coast.
makes sense. So now that begs a question. Where is this storm headed right now currently? I know the NHC is saying it's moving to the west at 2 miles an hour, but where is it exactly headed right now? We need to get that because we don't have any recon.
Yeah. Just a second. Let me pull up that radar again, or satellite again. If I remember correctly, it looks way less organized than it did earlier. That convection looks like it's starting to die down a little bit on the eastern side, and it looks like it's trying to develop convection way off to the northwest, trying to wrap around potentially. But honestly, it looks like it's stalled.
What is it?
It looks like it's completely stalled.
Dang. Wow. So it's not moving.
It's hard to tell though, because it is very messy.
Well, I'm looking for low-level cloud motions, and that's why I hate infrared. I hate infrared. I like visible because visible you can see things down to the surface, but infrared you cannot.
If I may suggest Cyclone, the Cyclone site that you show everybody every so often, that has a red, green, blue visible that's visible even at night, like right now. I'm looking at it. Honestly, yeah, I can't tell. It looks like the upper level spin is going to the northeast, I want to say, but it's really, really hard to tell because that's only part of it.
That's the thing that frustrates me with this is that now it's more messy. Where's the low level center exactly located? Because that's going to really be important. Because if this is moving 2 miles to the west or 3 miles an hour to the west, that's not a whole lot of movement, but it does make sense because, well, you calculate this 3 miles an hour. Let's see how far that would be in 24 hours in theory. Playing hypothetical game here. So 2 miles an hour times 24. That's 48 miles to the west. It would travel in a day. It's moving even 3 miles an hour times 24.
72.
That would be 72.
That'd be 72.
72 miles. That's decent. That's quite significant. So we need a really, really, I don't know. Maybe recon is going out in that again. Flying back.
Oh, let me look.
Nope,
let me
they're
look
not.
and see.
Nope.
Yeah, the last update was 23Z. That was 5 hours ago, I want to say, maybe 6 hours ago. But yeah, that is okay. So based off where the recon their drop zones, I can tell where the center is gonna be. I just gotta.
Because my gosh, this thing is already difficult to track. Already difficult to track.
Actually, I see a little bit of right where the center of this storm is, where there's a little bit more convection firing up. That area looks like it's going northwest. You got part of it looking like it's going northwest. You can actually see the vertical tilt of this system. If you look at the red, green, blue visible satellite imagery, you can see the tilt.
Red, green, blue water vapor?
Yeah, it's red, green, blue, false color visible. You can see how far apart the storm is tilted with height, and that is actually pretty significant. The tilt goes all the way into the very far northeastern corner of this storm.
Wow. So
you see it, right?
What website are you using?
I'm using the Cyclone WX site.
Oh, okay. That makes okay. Let me go to Cyclone WX site. All right.
Yeah, this has become my favorite to use for this hurricane season.
And so let's see. You go to storm floaters on Melissa.
Yep. Satellite and radar shows you red, green, blue visible.
Okay.
Yeah, as you play through it, you can see that tilt.
So it's water vapor. Okay, so I'm on Tropical Storm Melissa. Okay, so what type would it be? It would be infrared, right?
This is under visible products.
Oh, visible.
It's under the red.
Oh yeah,
Yes,
red,
that's what I've
green,
been
blue.
saying.
Okay, there it is. Okay, so let me loop this. and
midway
see.
through the loop, you can see a swirl up on the northern side of the convection. And then at the very end of the frames, you can see convection trying to wrap around and blow up near the direct middle of this storm, which
Oh, yes, I see that. Yes, okay.
is.
Okay.
Yeah, you can see how tilted that is.
Dang, that is tilted. Whoa. Oh, wow.
I'd almost say sideways.
Okay, you know what? I see the center now. I see the center. It's right here. It is literally right there is where the center is.
Yeah, right where that
Yep.
convective burst just popped up.
Yep.
Yeah, it looks like it's going northwest.
It really, to me, it looks like, hold on.
It looks like it's being torn apart.
Yeah, it might be
The
going
upper level is
northwest.
going. Yeah, the upper level looks like it's going northeast.
Yeah, so
It's getting torn apart.
yeah, because the vertical wind shear.
Yes, that would make sense considering it's coming from the west. It push it
However,
to
though,
the east.
we are going to need to keep an eye on that blob of very, very deep convection right to the north of that, because if that does try to wrap around on the up shear side, that could allow a redevelopment of this huge explosive mass like we had last night and into this morning. And that could allow the vortex to become a little bit less tilted, not completely vertically aligned, but it could help the system out a little bit.
Yeah, it could cover the low-level center again, like it did this morning.
So that's what we're gonna watch closely for. But right now,
but yeah, considering the most recent microwave passes look messy for this storm, they look way more unorganized than they did earlier. But considering the fact that this storm is more unorganized, but it still has all that ocean heat content, and the humidity values are insane in the Gulf, or excuse me, the Caribbean, I'm scared of what this storm could do.
Oh yeah, this is yeah, for sure. It's kind of like the girl that's possessed, but she's not showing that she's possessed, and she has this smile on her face, and then she shows her angry looking teeth, and she goes "Rah!" like that. So she's like trying. She's hiding, but then she's gonna show herself, and it's not gonna be pretty. By the way, the system is dealing with 30 knot of vertical wind shear right now. So that is what we have based on the latest deep shear analysis from the University of Wisconsin, which is a great site that I like to use. And so our system, okay, yeah. So there's the mid-level circulation right there. And here is the low. Yeah. So we're 25 knots or so. That is deemed unfavorable for this system. So you can see the shear vectors coming in around from the southwest like this is what we pretty much have right now. That vertical wind shear is expected to decrease over the next several days. And that's what is going to allow our system to really, really blow up. But right now, in the short term, it is dealing with a lot of vertical wind shear. And actually, if we go to RAL, real-time tropical cyclone, right here. Yeah, look at this shear right here. Of course, it's the GFS version, but I could all agree. We could all agree that the shear is going to be very light, right about in here somewhere, pretty much under 10 knots. And it's going to stay very light all the way through the next 7 days because the GFS has it over the Atlantic at this point. That's why it shows 40 knots.
Yeah.
But I really hope the GFS could fix itself because, man, is it upsetting to see the GFS not agree, despite the recon missions that have been ongoing, that there has not been any correction at all.
Yeah, that's another part of the concern too, because normally you know how the GFS likes to overperform these storms with that convection bias. The fact
Yeah.
that this time around it's actually been the opposite, even against the European model, that also has me deeply concerned as well. Especially with the fact that, like you said, is about 25 knots to 30 knots of vertical wind shear. Generally, you want about under 20 knots, under 10 knots, ideally, for the storm to really get itself going.
Oh, yeah.
Yeah. I mean, especially considering that the model intensity guidance has only been creeping higher and higher each time it comes out.
Is really
It gives you
concerning.
all the it gives you all the more reason to be prepared. And for all of you out there, you want to drown and don't drown,
Mm-hmm.
because this
All
rain from this
right.
storm will be catastrophic, to say the least, for the rain.
Oh, yeah, for sure. I want to
Mm-hmm.
see the European ensemble really quickly. Then I think I'm going to head off. I need to get some sleep. I got a busy day with my viewers tomorrow on YouTube. Well, today for a lot of you already at this point. And then I have to decorate for I'm helping out at church for a carnival on the 29th of October in the midst of this stupid hurricane. That's going to develop. So I am going to be overwhelmed with stuff. I'm going to be too busy. I might have to hire someone to upload for me one of these days. No, I'm just kidding. So,
Yeah, I'd say it's all hands on deck for this storm. I mean, especially considering where it's located. I mean, all these other storms have been deflected by upper level troughs such as Aaron and Gabrielle and Humberto. They all were deflected to the north and to the east. But considering where this is located, it's got massive concerns. Safe to say, massive concern.
oh, for sure.
Yes.
All right. So on the latest European ensemble, it is not as bad. Overall, the ensembles are more spread out, though. I don't like that. There's more disagreement in the ensembles tonight on the European than they were last night, which I'm a little surprised about, which doesn't help because that just means there's more uncertainty than what we first thought. But that's what it is pulling up on at the moment.
Yeah, David, if you look at the average sea surface temperatures in the Caribbean as well, for what this storm is going under, it's just shy of 30 degrees based off this website. It's just shy of 30 degrees. We're at 29.829 degrees Celsius. That is very warm for this time of the year. And then looking at the upper ocean heat content, let's see, right in.
Well, actually,
You can see that there's quite a lot of upper ocean heat content, especially in the northwestern Caribbean, where some areas are above 200 units.
dang. Well,
And then looking at the anomaly, it's just almost all completely way above the normal.
well, look at though, Logan. If you look at my screen here on the ship's model, then I'm gonna head out here in a little bit. Is that the sea surface temperatures on the ship's forecast, which stands for Statistical Hurricane Intensity Prediction Scheme, wants the system to move over a patch of even warmer water, 30.25 degrees Celsius.
Yeah, I see it. Yeah. Yeah, that is very concerning to say the least. I mean, the fact that the highest I'm looking at the ships now that I'm able to see it. The fact that the highest chances for rapid intensification are 65 knots in the next 3 days, that is alarming as well, especially considering where the storm is located. I do think one of the key players that could potentially, hopefully, limit the storm's capabilities is that humidity if it goes down below 50%, like it's suggesting later on,
Yeah, I
along
noticed
with that
that.
wind shear increase. Yeah, that wind shear increase as well. That's something else.
Yeah, that goes up to 40 knots. But you know what?
Mm-hmm.
I wonder if this is the GFS, how it analyzes it. I'm wondering if it's, yeah, you know what? I think this right over here is what the GFS is. And this is a whole different plot system from, I don't know where from.
Also,
But
you know, it could be also changing that wind shear as well. The actual storm itself, it could be causing upper level divergence to occur. So it could be increasing the shear because it's so different from what is expected because it's turning counterclockwise and clockwise up in the upper levels above it. That could be why the shear is also so high because it shows that the storm's potential intensity is actually higher later on as opposed to earlier on.
yeah, and despite that shear that is there, yeah, makes sense.
Hmm. A lot of it could be the actual storm itself is creating its own wind shear around the environment around it.
That could be it. Yeah.
That would be
Wow.
the reason. That could be the only reason I see the maximum potential still increasing, the intensity increasing. I mean, the ship's model has 110 knots, which would be about 125 miles an hour. Actually, let me look at this and make sure.
And then I'm going to have to head off here. But really quickly, for the viewers that are watching this, really quickly, man, there's a deep burst of convection. Right. I mean, that was a lot smaller earlier. Now it's really blowing up.
Mm-hmm.
Really blowing up right in here. And that's going to be, it's probably somewhere where the center is. Let me get that from the earlier recon mission. 75. So it's about,
Yeah, it's right in that area that you're talking about, that deep convection on that northern side of that big blob that's still intact. The center's right in there.
yeah, so it's about, I would say, best estimate is about 75 degrees longitude right now by about 14 and a half degrees. So that is,
Let's see.
so 14 and a half.
Oh, that's where you're saying the center is at 75 degrees? I'd say
Yes.
more like I'm gonna say more like 74 because it looks like it's trying to turn around that area in the 74 degrees west. It looks like it's trying to turn and go counterclockwise because you got the northern half of that blob going to the southwest. Well,
Yeah,
that other
but
area of the blob is going to the northeast and kind of spinning about there.
but see, the plane is finding though, because I'm looking for no wind at all, and there's no wind just to the west and the northwest of the last drop zone that was deployed on it. And that was marked at around 75 west by about 14.5 north in latitude. So that would be
Okay, that
that.
could make sense.
So
Yeah,
that
I'm looking at that.
so that deep convection then is way over to the northeast than what we're seeing right over here somewhere. So
Yeah, that seems about right.
it's moving northeast. No, we're not saying it's moving northeast. We're trying to locate where the center actually is. But it's not helpful when an
Yeah.
infrared is there and you need sunlight to, get low level cloud motions.
Mm-hmm.
Yeah,
Yeah, it's very hard to tell.
It's very slowly moving northwest. I agree.
Yeah, I might say it's about the same speed, maybe slightly slower, considering the environment around it. It does not even really look like it's been moving.
No, I think it's pretty much stalled at this point.
Yeah, that's something I could agree with.
As of 2 a.m., the NHC update, it was moving moving west at 2 miles an hour. So if we'll see with what the next advisory shows. I'll be asleep once that comes out.
Yeah, same here.
Could this be a direct hit? We don't know. We really don't know if
It's
this is
too
gonna
early.
be. It's way too early to even talk about potential landfalls and who's going to exactly get impacted. But I would, to be on the more generous side of the forecast, I am not leaning towards any landfalling right now. And this will miss this. I should say it should, not will or won't, but it should miss Jamaica to the south or east or west at the moment.
I agree with you. I agree. I think it's going to go to the south because of how vertically unstacked the system is, and the fact that it's not being steered by much. It's going to be heavily steered by that ridge that's going to build, and it's going to push the system out further to the west as opposed to the north. And actually, it's going to turn it west southwest.
Mm-hmm. Wow, HWRF is really liking that eyewall replacement cycle on its forecast. My goodness. That's as clear of an eyewall replacement cycle you could actually forecast on the HWRF model. That inner eyewall really collapsing. Quite interesting that it's actually forecasting that. Dang.
It might be also going off of some data from Hurricane Milton of last year. You remember how that storm reached 185 miles an hour, then its entire inner core just collapsed in on itself, and then it reformed an inner core?
Yep.
That might be part of the reason. It might be basing this off of past statistical data. So it might see that every time, because every time these storms get this strong, they become more and more unstable to the point where they collapse. And then they reform. That's what this eyewall replacement cycle does. It gets a little too unstable, so it causes the eye to shrink too much. So the storm tries to accommodate for that by increasing the wind fields at a larger radius and shrinking inwards, which constricts the inner eye wall, allows the storm to complete a cycle, then re-intensify, sometimes back to where it was before, sometimes stronger, sometimes never the same strength it was. For example, Aaron, it did an eyewall replacement cycle not long after reaching 160 miles an hour. It never reached Category 5 again, but it did re-strengthen after that eyewall replacement cycle was finished.
Mm-hmm. And speaking
Another
of,
good example is Beryl. That storm weakened through an eyewall replacement cycle, then re-strengthened immediately, and it can actually strengthen faster and more intensely than it was before the cycle began.
dang, wow. All right. So really quickly, okay, because it's getting kind of late here. Wow, HWRF is deja vu over Puerto Rico, or no, why do I keep on saying Puerto Rico? Over Western Jamaica. That system literally intensifies over Jamaica. Like, why? Why are you intensifying this right over a landmass? HWRF, oh my goodness. And that rainfall, whew, that is going to be catastrophic. That is going to be catastrophic if that actually comes to pass. You better hope that the HWRF is a liar, pants on fire, because man, that would be really, really, really devastating.
Yeah, let's hope we can get some gasoline to make sure their pants are on fire, because that is very deadly if that does come to pass.
That's a Category 4 hurricane. Like the eye is like western tip of Jamaica with the
So like
southern,
near Kingston?
something like that, and winds that are 120 to 130 miles an hour. That southern eyewall, man, that is pretty bad.
Hmm.
So this, yeah, Jamaica is in. I don't want to be the bearer of bad news, but boy, Jamaica is in the biggest impact threat right now for this system. I'm even surprised that National Hurricane Center has not issued hurricane watches on this just because of how close this could potentially get. But I can see why they're holding off on that right now until there's better model consistency. But yeah, Jamaica, definitely do not turn your back on this system at all. All right, well, anyways, it is 11:36 at night here. It is past my bedtime. I am tired because I've been up since 7 o'clock this morning, getting ready for my noon video earlier on. I'll probably do the same thing again because this system is definitely something that we are going to have to track for several days. This is not going anywhere anytime soon. You can see the 5-day forecast. It's not moving very much. And so, therefore, I just don't see this going anywhere for a while. So I will be on top of this at least once a day. If need to be, we'll be doing 2 videos a day, one in the morning, one in the afternoon. And how that would work is if I do one at like 7 or 8 in the morning, I would do one probably like at 4 or 5 in the afternoon to kind of space things out. And some live streams.
Want to make sure.
Yeah, some live streams in between.
Yeah, we'll definitely want to make sure in the meantime that we can get all you guys some much needed information on the storm, like what's observed for the winds, what's observed for the rain, the track, where it's going to go, all of that. Because who knows what's going to happen with what is going to most likely be called in history Misfortune Melissa.
Oh, exactly. But before I do go, for the 400 people that are watching this, if you have not subscribed to the channel, this is the time you should subscribe to the channel, or you need to subscribe and hit all notification bell icon on your TV, if that's on your phone, if that is on your computer, that's on your laptop. Get a way to get all notifications here on the YouTube channel, because we're going to be live streaming if need be on this system. Well, for sure, if this hits Jamaica, we're going to do all we can to live stream, even so there's no radar data on that, unless, well, we'll find it for you here on the channel as well. But yeah, I am pretty stressed out about this storm, and I am going to keep you all updated every single day. Even so, if I have to go to work at another job that I'm part of, I will keep you guys updated every single day, at least twice a day if needed. Love you guys. You guys mean a lot to me, and please stay safe. Stay ahead of the storm. Don't get hurt, and I'll be back with you guys tomorrow early afternoon with another update on Tropical Storm Melissa, as it remains a considerable threat to Jamaica, the Haitian Peninsula of Haiti in Hispaniola, Cuba, and even perhaps possibly Honduras and Nicaragua. You all need to be watching this, including the Cayman Islands there as well. Love you guys. Peace out. Share, like, and subscribe to stay up ahead of the storm here on my YouTube channel. And for more information too, while I'm not streaming or doing any videos in between, please visit nhc.noaa.gov for more information on this system. Once again, please visit nhc.noaa.gov for more information on their homepage. As always, have a great rest of your night on this fantastic Wednesday night, Thursday morning for some of you. I'll be back with you later on today.